All right, let's go to 6.5, graphs of polar equations. Okay, this is kind of a more obscure one-off type of deal, right? I mean, we talked about polar coordinates the other day, right? We talked about polar coordinates the last time we did, how to convert from polar to rectangular, how to go from rectangular to polar, whether it's a point or whether it's an equation, right? That's what we talked about. So today we're going to talk about the graphs of the polar equations. So let's go ahead and grab your calculators and let's see if we can graph this guy. Graph this for me. Everybody get a...
Mr. On, you're kind of standing in the way.
Huh?
Thank you. You were standing in front of the camera.
Like this?
Exactly like that, yes.
Okay, everybody get it? Everybody graph? Everybody, what did you get? What does it look like? A loop-de-loop. A propeller? And actually it's called a rose petal. Rose petal. Okay. Rose petal. So that's it. Let's see what happens if we change this.
Whoa, that made it double? No.
So when it was 3 theta, I had how many rose petals? I had 3 rose petals. And at 4 theta, how many rose petals do I have? 8. How about 5?
Probably 10. 5.
Just 5, right? You get just 5? Okay. What do you think you're going to get when I do 6?
12.
All right, let's verify that.
I think that's 12, but I'm not. Yeah, there's 12.
There's 12. Okay, there's 12. All right. So basically, when I am odd numbered here, I get the same amount. When it's even numbered, I get twice the amount, right, of rose petals.
Now I'm testing.
Okay. Now let's go back to our original.
But not if you do a really high number.
If we had 3. Now let's see what happens if I do the cosine. What happens if I do cosine instead of sine? Loop-de-loop is sideways now, right? So where the original, when we did the sine, it was symmetrical across the y-axis. What about the cosine? Across the x-axis, right? Okay? All right. So there's a difference there, okay? All right. So let's go to page 494. On the bottom of page 494, there are some things there where it says symmetry tests for polar graphs. To test for symmetry across the x-axis, we replace r theta by r minus theta. Okay, so when I had the r theta here, now I'm going to replace this to minus theta, 3 times minus theta, right? Which is the same basically as -3 theta, right? But this is also the same as, since it's if it's negative here, this is also the same as for cosine 3 theta. So you can see that when I put r and negative theta in, it becomes the original equation, which means that that is a test, so we know that it is symmetrical across the x-axis. The y-axis, number 2, says for r theta, instead of r theta, I put -r, negative theta. And when I'm testing about the origin, where r and theta is, I put -r and theta. And that's how you test for symmetry. What's another way to test for symmetry? just graph the darn thing, right?
You look at it.
Right? See what it looks like, okay? Okay, so example number 1. We just did example number 1. We did sine theta, okay, so example number 1. We started with 4 sine 3 theta. And I want to, what did the question say? Uses symmetry test to prove that it's symmetry plus the y-axis. So you go back to that purple box to test about the y-axis, where r is r theta. I'm going to put in negative r negative theta. So here I'm going to put negative r is equal to 4 sine 3, negative 3, like that. But it's sine, so sine's an odd function, right? So this becomes basically negative 4 sine 3 theta. And this is equal to negative r, so we just go like that. And I come back with the original equation. So when I put this guy in, I can get back the original equation, which means that it is symmetric across the y-axis. Okay, let's flip the page. Go to example number 2. Find the maximum r value of r is equal to 2 plus 2 cosine theta. R is equal to 2 plus 2 cosine theta. Is it just one theta or is it many thetas there? Just one theta. Okay. So first of all, what would be the maximum value here? This is always going to be 2. What is the maximum value of cosine theta? What's the largest that a cosine value can be?
1.
1. So therefore, the maximum value of r is going to be
3.
1.
2 plus 2 times 1. 2 times 1 is 2.
Yeah, that's right. We're getting there, okay? We're getting there.
4, okay? 4, all right. Let's go ahead and graph it. Go ahead and put your thing, graph it. A lily pad. A lily pad.
Sure.
Pretty close. Pretty close. It's actually called a limison curve.
Hey,
A
it started
limison.
out with the right letters. Okay.
A limison is, in French, limison stands for snail. It looks like a snail.
What kind of snails do they have in France? Are they?
They have
okay?
escargot. You ever heard escargot?
Or not that right?
So anyway, okay, so that's how, so let's go ahead and now graph it. If you graph it, you told me that it's a limison curve, and it looks like you said, a lily pad. Okay, so it looks like, I think it's this,
Yeah.
like this. Where does the maximum value occur? Where does the maximum value occur? Where is r the maximum? 4, right? Where is r is equal to 4? Where does r become 4? On the x-axis, right? When x, so basically, what is theta? If I'm on the x-axis. Theta is equal to 0, right? Theta is equal to 0, because when theta is equal to 0, this guy becomes 1. Does that make sense now? It's kind of coming together here. Okay, all right, good. So that's how you find the maximum value. We're good with that, blah, blah, blah. Yeah, okay, we're good. Okay, let's go back to another rose petal. R is equal to, so on example number 2, we're doing r is equal to 3 cosine 2 theta. And what is the maximum value over here going to be? No, look at here, look at here. It's gonna be 3, right? One cosine, this guy, the maximum value can be is 1, correct? All right. So let's go ahead and graph this. How many petals is it gonna have? It's 2 theta, so it should be 4. Go ahead and put them in. See if you get 4. Get 4, okay. Where does R become the maximum value of 3? Everywhere, not everywhere. There are 4 places, right? Yeah, so when theta is equal to 0, pi over 2, pi, 3 pi over 2, correct?
Yes.
Okay. And that's because when cosine is equal to 0, this is 0 becomes 1. When cosine is equal to here, I put that in, I get cosine pi, which is what? What is cosine pi? -1, right? -1. So it's -3, but the actual magnitude is still going to be 3, right? At -3, right? Okay. Same thing here. When I put pi in there, I get 2 pi, which is same as 0, which is still 1. The same thing over here. When I put that in here, I get cosine 2 theta, which becomes cosine 3 pi. Again, it becomes -1, so -3. Make sense? Okay. All right. Example number 4. Okay, so we're analyzing the rose curves. Okay, we're analyzing the rose curves, and let's go to the bottom where it goes straight to the blue box. Read that blue box and see if it makes sense to you. Ethan, are you there?
No, I'm just trying to look super weird.
You were like, I was like, okay.
Okay, all right, so are we good? Any questions on that? Okay, let's go ahead and call it end of part 1 here.
What a day.
Not a day.